welcome. In this video, I'm going to solve NEET 2018 question in physical chemistry. Under the topic of some basic concepts in chemistry, let's discuss the questions. A mixture of 2.3 gram formic acid and 4.5 gram oxalic acid is treated with concentrated sulfuric acid. The evolved gaseous mixture is passed through KOH pellets. Potassium hydroxide in pellet forms. Weight in gram of the remaining product as at STP, standard temperature pressure, will be. First of all, what is a reaction? Formic acid and oxalic acid were mixed together and reacted with concentrated sulfuric acid. What is the product of the reaction? Then what type of reaction is this? Anything react with sulfuric acid removes water from it. Basically, this is a basic. This is a formic acid. Then this is oxalic acid. If we react together, this is sulfuric acid. Sulfuric acid removes H2O. Simply. In the case of formic acid, there is a H2, there is one O. So H2O plus carbon monoxide is a product in formic acid alone. Okay. Then in the case of oxalic acid, the product is, then there is a 2 hydrogen, then 1 oxygen, then H2O plus 1 carbon monoxide, 1 carbon dioxide, carbon monoxide plus 1 carbon dioxide. Okay. Concentrated sulfuric acid first react with the formic acid to give water and carbon monoxide. Then sulfuric acid react with the oxalic acid to give water, carbon monoxide and carbon dioxide. They are asking the evolved gaseous mixture is passed through KOH pellets. Weight in gram of the remaining product at STP will be. Basically, the KOH pellets, what is the purpose of KOH pellets in this case? Okay, first of all, we need to know about it. Why KOH pellet is that? Because that KOH pellet absorbs carbon dioxide. Okay, basically, this sulfuric acid absorbs all the water molecules, especially all the water molecules are absorbed by sulfuric acid. Okay, then the KOH pellets absorbs carbon dioxide. The nature of the KOH pellets to absorb carbon dioxide to form potassium carbonate, because the reaction is KOH plus carbon dioxide gives K2CO3. The balanced equation is 2KOH. Okay, then there is a 2 hydrogen, so H2O. There is 2 oxygen, 2 oxygen, 4 oxygen, here 3 oxygen, here 1 oxygen, 2 hydrogen, 2 hydrogen. This is a equation because potassium hydroxide tends to form potassium carbonate. So potassium hydroxide pellets absorb carbon dioxide. The only remaining product is carbon monoxide. We need to find the carbon monoxide in gram. Simply. For this, we need to find the number of moles of, or else the number of molecules, anything, number of moles of formic acid and number of moles of oxalic acid. We can find easily the number of moles of carbon monoxide, then it can be converted into grams. Simply. How to do this? Let's see. Yeah, basically I wrote all the chemical equation behind this. Now we do the mathematical thing to find the number of grams. First of all, formic acid HCOOH, the weight of the formic acid, which means the molar mass of the formic acid, is 46. In the case of oxalic acid, the molar mass of oxalic acid is nothing but 90. The number of moles of formic acid, it is nothing but 2.3 divided by 46, because given weight divided by molecular weight gives number of moles. It is equal to somewhat 2.3 divided by, which means 46. If you use calculator, we can find the answer exactly, or else we can cancel the numerator denominator. as such. Okay. If we cancel this, we get 1 by 20. Okay, 1 by 20. Okay. Just like here it is 4.5 gram of oxalic acid, so 4.5 divided by 90, it also give 1 by 20. 1 by 20 moles, 1 by 20 moles. That is 1 by 20 moles of water and carbon monoxide in the case of formic acid. Here 1 by 20 gram of water, carbon dioxide and carbon monoxide. Water is absorbed by sulfuric acid. Carbon dioxide is absorbed by it is KOH pellet. The remaining is carbon monoxide. We need to find the gram of carbon monoxide. Here there is 1 by 20 moles of carbon monoxide is present. Here it is also 1 by 20 moles of carbon monoxide is present. Okay, as well as carbon dioxide is present. We don't want that. 1 by 20 moles plus another 1 by 20 moles. 1 by 20 plus 1 by 20. 1 by 20 plus 1 by 20. Denominator is same, so 2 by 20. 2 by 20 is 1 by 10. Simply 1 by 10. Okay, I am erasing some part. Okay, 1 by 10. Okay, 1 by 10 moles I find. So I found 1 by 10 moles. Unit is per mole. If we multiply by with the atomic mass of molecular mass of carbon monoxide. Molecular mass of carbon monoxide is 28 gram per mole. Per mole get cancelled 10, which means 28 divided by 10. It is nothing but 2.8. 2.8. The 2.8 is the answer here. C option has 2.8 as an answer. Okay, this is very simple. If you can do with this 1 by 20 moles, or else you can solve exactly. This is because this answer is exact answer. Okay, this is my convenience, so I took this. Just to cancel, there is a 1 by 20. It is in the fractional ratio. You can do anything. Okay. This is the next question. This is also one of the interesting question. In the case of number of molecules of water, so far we have seen number of atoms, but in this question there is number of molecules. It is a different type, but this is very easy. In which case number of molecules of water is maximum, which contain maximum number of water molecules. Okay, 18 ml of water. Water or water density is equal to 1. Then rho is equal to m by v. Then v multiplied by 1 is equal to m. So v is equal to m. Simply, then 18 ml of water is 18 gram of water. 18 gram is nothing but 1 mole. We need to find molecules. So the formula for number of molecules, it is nothing but number of moles multiplied by Avogadro's number. This is a formula. There is only 1 mole into Avogadro number. In option A, there is 1A. Option A, there is 1A. So I am erasing this to solve for another options. And option A has only 1 mole of water molecule. Okay. Option A has 1 mole of 1 molecule of water. For option B, there is 0.18 gram of water. 0.18 gram, which is nothing but how many moles? To find number of moles, given weight, which means 0. Let's solve this. 0.18 divided by 18. What is it? 0.18 divided by 18. It is nothing but if it is 1.8, 10 to the power minus 1. 0.18, it is a 10 to the power minus 2. Okay. 10 to the power minus 2 something, which is 0.01. 0.01 is number of moles. Okay, it is number of moles multiplied by Avogadro's number. It gives 0.01 in. This is number of molecules. This is very less. Option C, there is 0.0024 liter of water vapor at 1 atmosphere under 273 Kelvin. This is a standard temperature pressure STP. Okay, this is STP. First of all, we know at STP every gas has every gas occupies 22.4 liters. Here it is 0.00224 liter. We need to take ratio. The ratio is very simple, 0.00224 divided by 22.4 liter. Why we are taking this ratio? Because in water vapors occupy 0.00224 liter, but in general every vapors, which means every species in the gaseous state, occupies 22.4 liters. So we need to take ratio to find how the volume, how much volume is occupied by the water vapor with respect to the STP. With respect to STP. Okay. From this we can find how many how many moles of water is there. This much of, which means this much moles of water vapors occupies this much volume, because one water, which means 1 mole of water vapor occupies 22.4 liter. This is general, but in this case 0.00224 liters of volume is occupied by water molecules or else water vapor molecules. So how many water molecules there in the gaseous state? We can find from this ratio. If we take this ratio, the answer would be somewhat 0.0001. 0.0001, but this is multiplied by Avogadro's number because this is number of moles. Okay, this is a number of moles. This is a number of moles, then 0.0001 Na. This is very less. Then 10 to the power minus 3 moles, they gave moles. Very simple. Moles multiplied by Avogadro's number gives the number of molecules. This is moles multiplied by Avogadro's number. That's it. Option A has a maximum number of water molecules because that is a 1A. The other options contains, it is a decimal. 0.01, 0.0001, 0.001. Here it is 10 to the power minus 3, 0.001. Na. So option A has maximum number. In option C, there is only one twist. In 1 mole of any gaseous substance occupies 22.4 liter volume. In this case, 0.00224 liters of volume is occupied. So we need to take a ratio to find how many moles is there, then how many moles can occupy 0.00224 liter space.